I'm Coach Pete of Math Coach Me. I provide math coaching and tutoring services, and I also provide free lessons at my mathcoach.me site. This is the 8th lesson in my trigonometry series, and unique to my approach is the use of Desmos calculators like the one we're seeing here. This is one from the lesson. So Desmos is an exceptional tool for exploring math visually, and trigonometry is certainly that, a very visual math topic. Also unique to my approach is there is an online version of this lesson where you can interact with these calculators. You can set your own angles. I'm going to set this to, or actually I'm not setting the angle for the inverse, I'm setting the ratio. So I'm setting this trig ratio to 0.5, and I know, just looking at my special triangle here, that the sine of 30 degrees is the length of the opposite side, divided by the length of the hypotenuse, so it's that ratio, and I know that that's 1/2 or 1/2, and that's what I've put in here. The inverse sine of the ratio 0.5, so the inverse sine of 0.5 returns this in radians and this in degrees, 30 degrees. So that's what the inverse sine function does. Just before we leave here and get into the lesson, let's take a look at the functions available on a calculator. So we see the inverse trig functions. Wow, they've got their own buttons on calculators. There's got to be a lot of use there, right? So certainly very important functions. So for the 6 trig functions, we know those. There are corresponding 6 inverse trig functions. Let's get into the lesson. I do appreciate the likes for the videos, the likes, the comments, and the subscriptions, so please consider that. And let's start on this lesson and explore the inverse trig functions. The description for this video does include a link to the online version of the lesson, or you can go to the mathcoach.me site and then to lessons, and then locate this lesson, Trigonometry 8, Inverse Trig Functions. We're going to explore all 6 inverse trig functions. Let's take a look at this graphic first. We can see the sine function and the inverse sine function, or the arcsine function. The sine function is in purple, and we can see this. It's just showing the different sine ratios. Well, they're right on top of each other, but we're seeing the different sine ratios returned by the sine function for different angles, and the inverse of that. So for different ratios, we can see the inverse sine function returning different angles. So let's explore that in more detail. We're going to start first with the inverse sine function. It has 2 notations, sine to the -1 as x. This is read as the inverse sine of x, or arcsine, more the old school, arcsine of x. So this is read as the arcsine of x. And we know, looking at our special triangles, that the sine of 30 degrees is the opposite over the hypotenuse, so that's 1/2. And we can see that here in this first table. So we've got different angles and the sine of the angle and what's returned. So for the sine of 30 degrees, we can see that the sine of 30 degrees returns 1/2. This second table shows us the inverse sine function. And we can see those values are just flipped, for all of those theta and sine theta values, or x and y values. We can just see those flipped here. So for the ratio of 1/2, the sine of the inverse sine of 1/2 returns 30 degrees. Okay, so we can see that for all of those values. The domain of your inverse sine function is from -1 to +1 inclusive, and the range is from 90 degrees to +90 degrees, or -π/2 to π/2 inclusive as well. We can use this Desmos calculator to explore the relationship between the sine function, y equals sine theta, and the inverse sine function, f at x is equal, this one in blue here, f at x is equal to the inverse sine of x. And I have this slider here where I can change the different ratio and see what's returned from my inverse sine function. So for this ratio, let me get to around 0.5, this ratio of 0.5, it returns 0.523 radians as my angle, or 30 degrees as my angle. That makes sense. I can see that here. The sine of 30 degrees is 1 over 2, or 0.5. So the inverse sine of 0.5, when I pass 0.5 into my inverse sine function, it returns 30 degrees. So let's explore that for another angle. Let's explore that for the sine of 60 degrees. We know the sine of 60 degrees is root 3 over 2. So I'm going to enter that as my ratio. So root 3. I'm going to divide that by 2. And I can see that the inverse sine function returns, when I pass in root 3 over 2, it returns this in radians or this in degrees, 60 degrees. Okay, so we can see that. Now, also we see a lot of other points that are plotted here. So not only 60 degrees, okay, so pi over 3, that returns that, well, when I pass for 60 degrees, when I pass its ratio, 0.866, my inverse sine function returns 60 degrees, right? But this one here also returns 0.866. So all of these other points reflect, other angles that my sine of those angles would return the same ratio, 0.866. I can see it again at this coterminal at 7 pi over 3, okay? And this one here at 8 pi over 3. So all of those will return the same ratio, 0.866, and the inverse of that ratio is 60 degrees. We'll explore that in more detail in the next lesson. The inverse cosine function has this notation, cos to the negative 1 of x, or arccos of x. So this one is read as the inverse cosine of x, or the arccosine of x for this one. And again, I have a special triangle, our 30, 60, 90 triangle. And the cosine of 30 degrees we know as to be root 3 over 2, so the adjacent side over the hypotenuse. And we can see that here. Okay, so for the angle 30 degrees, the cosine of 30 degrees returns that ratio, root 3 over 2. And this second table is for the inverse cosine function. So all of those values are flipped. So all of those angles are y values, and all of those ratios are our x values. So for the ratio of root 3 over 2, the inverse cosine of root 3 over 2 returns 30 degrees. Our domain is all of the values between 1 and negative 1 inclusive, and our range of values for our inverse cosine function are from 0 to 180 degrees, or 0 to pi radians inclusive as well. I've set up this Desmos calculator to explore the relationship between the cosine function, here in red, and its inverse cosine function, here in blue. So first off, I can see that for the inverse cosine function, I can see that its domain is from positive 1 to negative 1, or negative 1 to positive 1 inclusive, and its range is from 0 to pi radian, or 180 degrees inclusive. I can use this slider to change the various ratios that I'm passing to my inverse sine function. Let me get that to 0.5 again. Okay, so at 0.5, I know that the cosine of 60 degrees is 1, the adjacent side over the hypotenuse, 1 over 2. So the cosine of 60 degrees is 1/2, or 0.5. So if I pass that to the inverse cosine function, okay, inverse cosine of 0.5 returns 60 degrees. Okay, so that's certainly what it does. And let me explore it for one other angle. Let me put in here, let me put in here 30 degrees, or root 3 over 2. Okay, so when I pass the ratio for 30 degrees, which is root 3 over 2, I can see that the cosine of 30 degrees is root 3 over 2. When I pass that to the inverse cosine ratio, I am returned 30 degrees, or 0.523 in radians. Next up is the inverse tangent function. So inverse tangent of x, or known as arctan of x. So for 30 degrees, we know that the tangent ratio of 30 degrees is the opposite over the adjacent, 1 over root 3. We see that in this first table here for the tan of theta. So if theta is 30 degrees, the tan of 30 degrees returns the ratio 1 over root 3. For the inverse function, we can see that when the ratio of 1 over root 3 is passed to the inverse tan of function, it returns 30 degrees. The domain is all real numbers, okay, so it can be all real numbers, and the range is from minus 90 degrees to 90 degrees exclusive, okay? Can't hit those asymptote values. This Desmos calculator is set up to show us the relationship between the tangent function and the inverse tangent function. I have the tangent function in red here. I've got the asymptotes marked as well between negative pi over 2, negative 90, and 90 degrees, and then repeating every pi radians, every 180 degrees. And I also have for the inverse tangent function in blue here, I've got asymptotes at y equal to pi over 2, or 90 degrees. Okay, so that is the upper bound of the range of the inverse tangent function, and the lower bound is minus 90 degrees exclusive. It can never quite get there. I can use this slide. Actually, I'm going to just focus in on this range. Just want to focus in on one period of this range between negative pi over 2 and pi. So between that range there, if I move this slider, I can change the ratio that I'm being passed to the inverse tangent function. I can change the ratio, and I can see that as I change the ratio, the returned angle is getting closer and closer to pi over 2, but it never quite gets there. Okay, and I can see that going in the opposite direction as well. As I pass it a larger and larger negative ratio, negative 9 right now, and keep going more and more negative, it approaches negative 90 degrees, but never quite gets there. And I've got the asymptotes marked for the range as well of our inverse tangent function. So if I were to pass it, let's explore the tangent of 30 degrees. Tangent of 30 degrees would be 1 over root 3. So let me enter that in there. 1 divided by root 3. And for 1 over root 3, I can see that the inverse tangent function returns 30 degrees. Okay, so when I pass that value, it returns 30 degrees as expected. The inverse cosecant function can be expressed as cosecant to the negative 1, or the inverse cosecant of x, or the arccosecant of x. So we know that our sine function for the sine of 30, that's the opposite over the hypotenuse. So sine of 30 is 1 over 2, 1/2. The reciprocal of that, the cosecant of 30 degrees, will be the opposite over the hypotenuse over opposite, so 2 over 1, or 2. And we see that here. For 30 degrees, the cosecant of 30 degrees returns a ratio of 2. And when we take a look at that in the inverse cosecant table of values, that we see that for when we pass a ratio of 2 to the inverse cosecant function, it returns 30 degrees. Okay, if we pass a ratio of negative 2, it returns negative 30 degrees. So the range, the domain of the cosecant function is all ratios that are less than or equal to -1 or greater than or equal to 1. And the range of values is all angles from negative 90 degrees to 0 degrees exclusive, or all angles that are greater than 0 degrees all the way up to 90 degrees. Let's continue to explore the relationship between our cosecant and inverse cosecant function using this Desmos calculator. I have the cosecant function here in red, the inverse cosecant function in blue here. And I'm going to restrict the cosecant function to one period, okay, from minus pi over 2 to pi over 2, so just over that 180 degree span. And we can see that for our cosecant function, the cosecant of 90 degrees returns a ratio of 1, and we can see the inverse of that. The inverse cosecant of the ratio 1 returns an angle of pi over 2, or 90 degrees. And we see that for the negative version as well. I can use this slider to approach 0. Okay, so as my cosecant function starting from 90 degrees, as it's approaching 0 degrees, it's returning a larger and larger ratio. And I can see that reflected here in the inverse cosecant function. So as the ratio increases, it's returning a smaller and smaller angle that approaches 0 but never quite gets there. And the opposite happens in the negative direction as well. So if I just pass a value of 2, so 2, let's see. So the cosecant of 30 degrees, well, the sine of 30 degrees is 1 over 2. The cosecant of 30 degrees is 2 over 1, the reciprocal of that. So when I pass a ratio of 2 to my inverse cosecant function, it returns 30 degrees. Okay. If I change that to a negative 2, it returns negative pi over 6, or negative 30 degrees. The inverse secant function is expressed as secant to the negative 1 of x, or the inverse secant of x, or the arcsecant of x. And we know that the secant function is the inverse of the cosine function, so the cosine of 60 degrees would be 1 over 2, adjacent over hypotenuse. So the secant, the reciprocal of that, the secant of 60 degrees would be the hypotenuse over the adjacent, 2 over 1. And we see that reflected here. For 60 degrees, the secant of 60 degrees returns a ratio of 2. And we can see the inverse of that here. So when we pass a ratio of 2 to our inverse secant function, it returns an angle of 60 degrees. The domain is all ratios that are less than or equal to negative 1 or greater than or equal to 1. And the range is all angles from 0 to 90 degrees, excluding 90 degrees where there's an asymptote, and greater than 90 degrees up to 180 degrees. This Desmos calculator includes a secant function here in red and a inverse secant function in blue. And I'm going to restrict the secant function over one period from 0 degrees to 180 degrees. And as well, let me set this to 1. So here at 0 degrees, my secant function returns a ratio of 1. And I can see that on my inverse secant function, if I pass a value of 1 or a ratio of 1 to my inverse secant function, it returns 0 degrees. As I increase the size of this ratio, okay, it's getting larger and larger and larger, I can see that the angle that it's returning is getting closer and closer to 90 degrees. I've got that marked here with this asymptote at pi over 2 at 90 degrees. So it's getting closer and closer to that asymptote, but it never quite gets there. And then in the other direction, the same happens, okay? Getting closer and closer to 90 degrees, but never quite gets there, okay? Okay, so I'm going to set this to 2. Okay, and this is exploring this angle of interest, 60 degrees. So the cosine of 60 degrees is 1 over 2. So the reciprocal of that, the secant of that, is 2 over 1. And I can see that here on my secant function. I have at 60 degrees, at pi over 3, 60 degrees, I have a ratio of 2 that is returned on my secant function. If I pass a ratio of 2 to my inverse secant function, it returns pi over 3, or 60 degrees. If I change that to negative 2, now it's returning an angle of 120 degrees. The last of our inverse functions is the inverse cotangent function. So we have one notation here, the inverse cotangent of x, or the arccotangent of x. Thinking back to our tangent function, the tangent of an angle is the length of the opposite side over the adjacent side. So the tangent of 30 degrees would be 1 over root 3. And the reciprocal of that for a cotangent function, the cotangent of 30 degrees would be root 3 over 1. And I can see that here. For the angle 30, the cotangent of 30 degrees returns a ratio of root 3. And for our inverse function, for the inverse cotangent function shown in this table, if we pass it a ratio of root 3, the inverse cotangent function returns an angle of 30 degrees. The domain is all real numbers for the ratios, and the range is from 0 to 180 degrees, but excluding 0 and 180 degrees where it's undefined on the cotangent function. This Desmos calculator is set to show the relationship between our cotangent function in red and our inverse cotangent function in blue. And let's see, I'm going to again restrict this. Okay, so I'm going to restrict this to one period, one 180 degree period from 0 to 180 degrees. Okay, so I can see one complete cycle of my tangent function here. And at, as we're approaching 0 degrees, from greater than 0 degrees, my cotangent function is returning ratios that are approaching positive infinity, and they're getting smaller and smaller as we're approaching 90 degrees, and at 90 degrees returns a ratio of 0, and then as it approaches 180 degrees, it's going to return ratios that begin to approach negative infinity. And right here at 0, so when I see my cotangent function at 0, my cotangent function at 90 degrees returns a ratio of 0, so that's where it passes through the x-axis, and I can see the corresponding point on my cotangent or inverse cotangent function. So if I pass to my inverse cotangent function 0 degrees here, it returns the value of 90 degrees, or pi over 2 radians. Now, let's begin to move this slider, and as we get larger and larger in terms of the ratio that I'm passing to my inverse cotangent function, this begins to approach 0 degrees, and this angle gets smaller and smaller and smaller. Approaching 0, never quite gets there. In the other direction, as we are passing negative ratios that are getting increasingly large, it's approaching 180 degrees, but again, it will never quite get there. Okay, so I'm going to set this to, let's set this to root 3. Okay, so at root 3, when my ratio is root 3, so that corresponds to this. The tangent of 30 degrees is 1 over root 3. The cotangent of 30 degrees is root 3 over 1. And if I pass root 3, that ratio, to my cotangent function, it returns pi over 6, or in degrees, 30 degrees, as expected. If I change the sign on that to be negative root 3, it returns the corresponding negative angle for that. Okay, so at negative root 3, the ratio, so basically at 5 pi over 6, or 150 degrees, we have the ratio returned of negative 1.732. And if we pass that to the inverse cotangent function, it returns 5 pi over 6, or 150 degrees. That concludes this lesson on the inverse trig functions. If you like my approach, I certainly appreciate the video likes and the follows and the comments as well. And in our next lesson, we're going to take a look at a couple of interesting concepts. We're going to look at the cast rule, and we're seeing a depiction of that graphically here on the screen right now. We're also going to take a look at reference angles, two tools that are very useful in solving many trig problems. So I hope to see you then.